Hello students, good evening all. So welcome to our next session. So this is our second session of chapter linear inequalities. Right, so in our first session we just had a quick introduction part and basic properties and all we have discussed. Right, in our first session of linear inequalities. So today we'll just continue that part. So before get started with our session, we'll just have a quick overview of what and all we have covered in our previous session and what in particular we are going to cover in our today's session of linear inequalities. So quickly we'll just have our overview here. So first, in our previous session, we just covered with the introduction part, like basically we started our previous session with equality and then we jumped into inequalities and then we have discussed our basic intervals. So that and all we just had an introduction, and after that in detail we have discussed the basic properties which are related to our inequalities. So which are very important here. Right, because whatever inequality we are trying to solve and get the solution for that inequality, so we are going to apply our basic properties, isn't it? So without basic properties, without the idea and clear vision of our basic properties, we cannot actually solve our linear inequalities. So we have clearly discussed our basic properties, what and all we can do, when the inequality can change. So those already we have discussed. So coming to our today's session, we are going to look into the solution of our linear inequalities. Right, solution in the sense nothing but simply solving our given linear inequality and writing the answer like the solution in terms of interval. So whatever it is according to the question which is mentioned. Right. So after the solution, we are going to look into some operations here. So what are these operations? So if a linear inequality is given, we know how to find the solution. So by applying our basic properties, it is easy for us to find the solution of our linear inequalities. So then comes our next step, that is operations. So operations in the sense, here they will be giving more or two or more than two inequalities will be given. And for those two inequalities, there will be an operation which will be given, and based on that particular operation, we have to find the solution of that corresponding given linear inequality. So that we are going to discuss in our today's session. So after the operations, we are going to jump into the graphical solution. So if it is given in a normal inequality, if we want to find the solution in normal terms, we know how to simplify it and find the solution of it. So how we'll be writing or representing the same solution for the linear inequality in terms of graphical, in terms of our graphical point of view. Right, so you guys have already familiar with plotting a graph. You guys are already done these plotting of a linear graph and all in your elementary sections 9th and 10th. Yes or no? So we are going to apply the same case, but usually in your sections what you have learned, you have plotted the graph when you will be having a equality, that is an equal to. But here we are going to plot our graphical solution for the inequalities. Right. So for finding the graphical solution of our inequalities also, we are going to use our equality. So that is how we are going to find the graphical solution, by using our equality itself. So how we are going to do that and how we are going to find the graphical solution in detail, we are going to see in our today's session of linear inequalities. And the next and very most important method in our linear inequalities, that is nothing but wavy curve method. So if we guys are familiar and handy with this method of wavy curve method, then we could easily solve any given linear inequalities within seconds. It's as simple as that. Right. So that's why we should be very alert, and we have to pay more attention when we are dealing with this method of wavy curve method. So why I am saying it's very easy, it will be very easy. It actually makes our inequality to solve within seconds, so that you will be understanding when we are actually solving questions using the wavy curve method. You will itself realize that it's very useful, and it's it actually reduces our time, right? So in and overall, so these are our typical things that we are going to cover in our concepts, that we are going to cover in our today's session of linear inequalities. Okay, Ridhishri is here. Okay, so I hope you guys are clear with it. So I'm mentioning again, you have to be very clear and pay attention while dealing with the method of wavy curve. So let's start with the first one, guys. So basically, what is solution of any inequality? So if we see a equality, so let's take a equality. So if we are trying to find the solution of any equation, what does it mean? Solution is nothing but the values of the variable, right? So if I am saying x plus 2 y is equal to 1, if this is my equality, so I am just taking an example of equality here. So if I ask what is the solution of this equality here, the solution of equality is nothing but the values of these variables x and y, which actually satisfies the given statement. In the same manner, even for inequalities, it's the same thing. Solution is nothing but it will be the values of our variables which makes the given statement true. Right, so that is our basic definition of solution. So as we have seen the definition, and along with that we actually covered our basic properties. So now in our previous session we just had a very basic level of solving inequalities we have seen. So now let's see how to solve a linear inequality when the information is given in terms of a word problem. So let's quickly solve 2-3 questions related to based on our word problem type of thing, and then we can jump into our next concept. So here comes the first question, guys. So can you guys it's a word problem. So I know that you have already done questions related to word problems and all. So can you guys just read out the given information, and can you guys convert this into our mathematical form? It's nothing but our equation, or in our mathematical terms. Quickly. So it's a word problem here. So quickly convert this into our mathematical format so that we can find the answer further. So quickly just let me know the inequalities you are getting. So that will be fine. Because we are trying to convert the given word problem into an inequality and see how it comes. So I'm not asking you to find the solution here. So that we'll be seeing next. So first thing we have to write the inequality. So we could be able to find the inequality which is given in this word problem. So quickly guys. So we'll just read the question here. So here the question is, find all pairs of consecutive odd natural numbers, both of which are larger than 10. So here pair in the sense we'll be having two consecutive odd numbers. If for suppose I have taken x is my one odd number, so what will be the other? As they are consecutive, so the other will be x plus 2. Right. So both of which are larger than 10. So both are greater than 10, which means if my x is greater than 10, it's obvious that my x plus 2 will also be greater than 1. So what is my first inequality which I am getting here? That is x greater than 10. And the other condition which they have mentioned here is such that their sum is less than 40. So the sum of these two consecutive odd numbers is less than 40. That is x plus, and the other consecutive number is x plus 2. So the sum here is less than 40. So what will be our second condition? That is our second inequality here. X plus 2 less than 40. That means 2x plus 2 less than 40. Right. So we can take this to other side. So it will become 2x 38, and we can divide the whole by 2, which will become x less than 19. So here we are having two conditions, x less than 19 and x greater than 10. So if we observe from the given word problem, we have converted the given information into our inequalities. But here if you observe, we are having two conditions. So that one is x greater than 10 and the other is x less than 19. So now the problem is, we know that if we are having a single inequality, it's easy for us to find the, like we know how to do the solution and how to find the solution of it. But here if you observe, we are having two. Then what is the trick here? How will be finding the solution? So we have to find the x such that it will be satisfying both the condition. Yes or no? So it will be combining the both. Hence our answer will be, the x value will be lying in between 10 and 9. That is, so this will be our x values, that is the consecutive pair of odd numbers where both the numbers are greater than 10 and their sum will be less than 40. Right. So this is our first question here. So let's move on to the next question. I hope you guys here understood how to convert the given word problem into our inequalities. So that's the main thing here. Right. So we have to convert the given word problem into inequalities. So once we could able to convert into inequalities, we can easily try and solve the inequality and get the final answer. So let's do one more. So here comes one more word problem. So quickly guys. So I have clearly explained the last one. So can you guys try and write the, at least you could able to write the inequalities, because we are actually starting how to solve the inequalities. So if you could able to write the inequality from this, so by our future lectures, you will be clear with how to find the solution also. So first you just let me know what is the inequalities here from the given information. So if you're having any questions, you can let me know. You can just write it down in the comment section so that I can reply you. So read the given question carefully guys and try to answer. So take your 2 to 3 minutes. So it's a question related to marks. So the marks obtained by a student of class 11th in first and second terminal examination are 62 and 48. So here they have given the marks obtained by a student of class 11th in first and the second terminal examination. So in the first terminal examinations, the student scored 62, and in second terminal examination, the student scored 48 respectively. So find the minimum marks he should get in the annual examination to have an average of at least 60 marks. Right. So here you can observe the key point, that is they are talking about he should be getting an average of at least 60. Right. So what do you mean by this word at least? Whenever the word here at least comes, it will be starting from the minimum. That means whatever the value here given, that is minimum, and it will be going until the maximum. So whenever the word at least comes here, so that states that it will be from minimum value to the maximum possible value. Similarly, there is one more word, that is at most. So when we are having the utmost, it's the reverse of it. That means it will be starting from the maximum and it will be going until the minimum. So you will be learning, you will be seeing these two words, at least and at most, frequently when we are dealing with the chapter of probability as well as permutations and combinations. Right. So let's deal with it, and let's try to convert the given information into our inequalities. So the marks obtained by a student of class 11th, so terminal 1 and terminal 2, 62 and 48. So the average should be at least 60. So that what can be his annual examination minimum marks? So average, right? So it will be 62 plus 48. So if I assume my score, the boy scored, the student scored in annual exam, let it be 60. So as it's an average, so it will be 62 plus 48 plus x divided by 3. Right. And here they have mentioned so that he should have an at least average of 60 marks, which means he should get a minimum of 60 marks. Right. So the average of all these three exams, that is first terminal, second terminal and the annual examination, should be a minimum of 60 marks. So it can be greater than 60 also, but a minimum of 60 must, and less than 60 should not be possible here. So that means my minimum value here is 60 and he can get more than 60 also. So that's why my inequality here will be greater than equal to 60. So now what is our inequality from the given information? So the average of the three scores, 62 plus 48 plus x by 3 greater than equal to 60. So let's simplify it. So our aim is to find the minimum marks he should get in the annual examination. So 62 plus 48, 110. So 110 plus x divided by 3 greater than equal to 6. So if I multiply with 3 on both sides, it will become 110 plus x greater than equal to 180. Then I can subtract with 110 on both sides. So x greater than equal to 180 minus 110, that means x greater than equal to 70. That means the student's annual examination score should be a minimum of 70. Right. If he scored a 70 marks in his annual examination, then what will be his average score? Then his average will be turning out to be 60 marks. Right. If he scored greater than 70, correspondingly the average will also be increasing here. Right. So we have to find the minimum marks. So what is the minimum marks that he should score in the annual examination? That is nothing but 70. So the minimum value of x will be equal to 70 here. So I hope you guys are clear with this question. It's a very easy question. So once we could able to construct the inequality, and the other steps are easy, just the simplification of the inequality. So I hope you guys got this one. So if you still have any questions, any queries, please let me know guys. If not, we can just move ahead with our next question. Any doubts? So I hope you understood this one. So let's move on to the next question. So it's a simple inequality because we are now trying to deal with the solution of inequality. So a simple inequality I have given here. So try and solve this inequality and let me know what is the solution of it. Come on guys, quickly. Okay, no doubts, Sari. Okay. So here a very simple inequality I have given so that you can have a handy and practice with finding this solution of linear inequalities. So quickly let me know the answer. So quickly guys. So what's the inequality which is given here? A simple one, 7x plus 3 less than 5x plus 9. So quickly I'll be giving one more minute. So quickly let me know the answer. Okay, Dinesh Kumar has given the solution of inequality x less than 3, correct? So simply how we'll be solving? So we can take the 5 here. So 7x minus 5x, it will be 2x. And here 9 minus 3, it will become 6. If I divide by 2, it will become x less than 3. Right, so how we'll be representing this in terms of our intervals? So less than 3, so it will be going until minus infinity to 3. As our 3 is not equal to, that means it is not included, so open brackets. So here my solution of this inequality is nothing but x belongs to minus infinity comma 3. So this is the, we'll be representing our solution of inequalities using our intervals. Right, so you can observe which kind of interval is this. This is our open interval. Right, so let's move on to the next thing, that is our operations. Right, so what is this operations here? So operations is nothing but if we are having a more than one inequality, right? So if we have to find the solution when we have the inequalities more than one, then there will be an obvious operation between those inequalities so that we can solve the given inequalities. So what is the possibility of that operations? So it can be, the first possibility is it can be a union operation. That means a combine. Right. So what is our union in our sets? Union is nothing but both the elements will be included. Right. So if I have taken two sets, A and B. So what do you mean by A union B? So A union B, it's actually states that it will be including all the elements of A as well as all the elements of B. So the same thing here for our inequalities also. So if it is union or if you could see a words like union, combine, or, so these all actually meant to the operation of our union. So union in the sense directly both the solutions will be taken, consider, and then they'll be taken as union. So let's see one example. X greater than equal to 1. That means what is our solution for this? So let me take it and number line so that it will be easy. So here comes 1. So greater than and equal to. So it starts from here. Sorry, greater than, right? So it will be this. Right. And the other is x less than 0. Which means here I am having 0. So less than 0. So whenever I am having like this, I can take the union of both the solutions, because here the operator between the two inequalities is OR. That means my union, combination of both the solutions. So what is my solution for x greater than equal to 1? So x belongs to 1 comma infinity, where for 1 it will be a closed bracket, and x less than 0, x belongs to minus infinity comma 0. Right. So as here my operation is OR, which is a union, I can combine both my solutions of the inequalities. Then what will be my final solution here? My final solution of x here will be minus infinity comma 0 union 1 comma infinity, which means both are considered. So both will be combined, as we are having the operator between these two inequalities is union. Right. So what will be the second operator? So the second operator will be opposite of it, that is our intersection. So what do you mean by intersection in our sets? Intersection is nothing but a common area. If we are talking about two sets, what is the intersection of set A and set B? It is the common elements of these two sets A and B. So here also the same thing. If we are having two inequalities and the operator is AND, then we have to take the common interval, that is common elements which satisfies the condition. So let's understand this with an example. So here what is my first thing, that is x greater than equal to 3. So what is my solution for this? X belongs to 3 greater than 3. So it will be infinity including 3. So what is my second? X less than 2. So here x belongs to minus infinity comma 2. So is there any common solution for these two inequalities? No, right? So let's confirm by locating it on a number line. So let it be 0, 1, 2 and 3. So for the first inequality, the x values will be greater than or equal to 3, which means it will be starting from here and it will be going like this. So that will be my first solution. And for second, it will be x less than 2. So it will be from here. So if we observe, these two are two separate solutions. There is no common intersection or common interval for these two inequalities. So, but here my operator is AND. So hence I will be writing my x belongs to null set. That means I don't have any solution here. If it is a OR operator, then I can combine both the solutions of the inequalities and I can write my solution. But here the operator is intersection, that is AND. I don't have any common area here. So that's why my solution here will be a null set. So this is how we will be applying and using our operations and writing the solution of the inequalities. Right. So let's moving on ahead. So let's solve a question here which is related to our operations. So quickly. So first I have given two inequalities. So first you can simply take the two inequalities separately and simplify them separately and write the solution of them. Two of the linear inequalities separately. And at the last, observe what is the operator given in between these two linear inequalities and then see what will be our answer. Come on guys, quickly. So I have given two inequalities and the operator between these two inequalities is and. That is nothing but our intersection. So did anyone got the answer guys? So what is the first inequality? So 3x minus 7 less than 5 plus x. Can you guys tell me what is the solution for this inequality which you got? I'll just give you 1 more minute so that you can just find the solution. So by now you guys should be familiar with how to solve these basic inequalities because we have clearly seen our basic properties. So it's just that we are just applying our basic properties and simply solving our basic linear inequalities. So in further, we'll be seeing a typical different method of inequalities, different variations. So that we'll be seeing in the next future sessions. Okay, Dinesh has given. So x less than equal to, okay, x greater than equal to 2 and x less than c, correct. So what will be the intersection here? So my question is, I have given an operator. So can you guys tell me what is the intersection and combined complete solution for this? So for this it will be 2x less than 12. So x less than 6. This is my first solution. That means x belongs to minus infinity comma 6, isn't it? So what about our second? So 11 minus 5x less than equal to 1 here, right? So I can take this to the other side. So minus 5x less than equal to 1 minus 11, that will be minus 10. So now I can divide with minus 5. So it will become x greater than equal to 2 because I am dividing with minus number, that is negative integer. So it will become, the sign of the inequality will be changing. So that is, it will turn out to be greater than equal to 2. That means my here solution will be greater than, so 2 comma infinity where 2 is included. So these are my two separate solutions of the two inequalities here. So but there is a operator between these two inequalities, that is nothing but and, which is a intersection. So let's it's easy when we plot the elements on the number line to find out the intersection. So it will be 2 somewhere here and let it be 6 somewhere here, right? So first solution 6 to minus infinity, so this will be the thing, and for the second it will be 2 to infinity, so which includes 2 to infinity. So if you observe what is the common, that is intersection area which includes both of the solutions, that is from 2 to 6. So my final solution will be x belongs to 2 comma 6 where 2 is included and 6 is excluded. So this is my intersection area and my final solution of this given two inequalities with the operator of AND, that is x belongs to 2, 6. Right. So I hope you guys understood this intersection part. So for the same question, if I have changed only the operator for OR, so instead of AND, I have changed my operator to the OR. So now can you guys tell me what is the solution and what is the interval here for this quickly? It should be the union. So can you guys write the union of these two solutions and let me know what is the interval? What is the solution of this inequality in terms of intervals? Quickly. So come on guys, the solutions will be the same thing for each of the separate inequalities. So for 3x minus 7 less than 5 plus x, what is the solution we have seen? This will be x less than 6. And for this 11 minus 5x less than equal to 1, we end up having x greater than equal to 2. So let's again plot it on our number line. So 0, 2 somewhere here and 6. So what is the first one? Less than 6. Right. So it will be the entire thing here. Right. And for this, x greater than or equal to 2. So equal to 2 and greater than 2. Which means I'll be having my all the real numbers here. Where including my 2. Right. So how I can represent that? So here my interval will be x belongs to minus infinity to 2, where 2 is included, union 2 comma infinity, again where my 2 is included. So this is my combined solution here with an operator OR. So we have seen what will be the solution with our operator and that is our intersection, and just now we have seen what will be the solution with an operator OR, that is a union. So now I hope you guys are familiar with these two operations of union as well as intersection. So if you have any questions in these two questions or in these two operations regarding anything of operations, you can let me know so that we can have a quick discussion on it before getting into the next concept. Come on guys, quickly. So I hope you guys might have understood how we have done this union operation as well as our intersection operation here. So I have helped you by giving an example so that we can understand even easily. Can we guys move ahead? Okay, we'll just move ahead with our next question. So here comes one more. So we'll just finish with this and we can jump into our next concept. So let's solve one last question and we'll just jump into our next concept of graphical solution. So quickly guys, at least let me know the solution of it quickly. Very easy, just within seconds you can find the answer. Quickly let me know the answer for this inequality. Quickly let me know the solution. Sariu, Riddhi and Dinesh. So what's the inequality which is given here? So minus 8 less than equal to 5x minus 3 less than 7. So how will be solving this? Come on guys, anyone? Answer what is the solution? Just take 1 more minute and then I'll just explain you and give you the answer here. Okay, let me just give you the answer here. So here we are having minus 8 less than equal to 5x minus 3 less than 7. So here we should have in terms of x. So what I can do? So here you can actually solve it as two separate thing, or else you can just simplify it as it is. So I can take this minus 3. If I am taking this minus 3, I have to take with both sides. Right. So to eliminate this minus 3, I am just adding plus 3 for the whole equation. That is minus 8 plus 3 less than equal to 5x minus 3 plus 3 less than 7 plus 3. So for the whole equation, what I have done to eliminate the minus 3, I have added plus 3. So now this term will become minus 8 plus 3 will be minus 5 less than equal to 5x plus 3 minus will be getting cancelled and I'll be remaining with 5x, and here 7 plus 3 it will be 10. So now here we are trying to find the solution. So the coefficient of x should be always 1. So here I am having 5. So I should be eliminating this 5. So how I will be eliminating? By dividing with 5. So for the whole equation, I should be dividing with 5. So this will be minus 5 divided by 5 less than equal to 5x divided by 5 less than 10 divided by 5. So now if it get cancelled, it will be minus 1 less than equal to x less than 2. So this will be my solution here. Minus 1 less than equal to x less than 2. So this will be my solution of this inequality, guys. So we know how to form it, this one. Right. So minus 1 comma 2, where 2 is open brackets and minus 1 is closed bracket. So my x belongs to here minus 1 comma 2 with closed bracket for 1. So this will be my solution of this inequality. Right, so I hope you guys are clear with it. So let's move ahead with our next concept. So the next concept here that we are going to cover is graphical solution of our linear inequalities in two variables. Right, so in general, how we'll be plotting our graph for any linear equation? So let's talk about an equation first, then we can jump into our inequalities. So we know how to plot any given linear equation in terms of our graphical form. Right. So for that, we should be requiring our x-axis as well as our y-axis, isn't it? So here what I have taken, this is my x-axis and this is my y-axis. Right. So before getting into the location or plotting of our linear equation, so let's just understand few things here. Right. So for this coordinate axis, x and y axis, so this is my graph. Then if I am having a line like this, right, so then this entire part, so the right side of the line part will be called to be right half plane, and the left side of the line, so this entire part will be called as left half plane. So this entire part will be called as right half plane if we are having a straight line like this. So instead of a straight line, if it is a cross line like in this figure, which is shown in this figure, then for this cross line, I would slanting line, we can say, I won't be taking the parts as left and right. So instead of that, I'll be talking as lower part as well as upper part. So here the area which will be below the line, that will be called as lower half plane, and the above part will be called as upper half plane. So these two things you can keep in mind, because while writing the solution, sometimes in options you might have seen it will be the upper part, left hand part, lower part, right hand part. So they won't be directly giving, because here for inequalities we won't be having the exact solution here. It will be a bunch of solutions. It will be a group here. It will be a typical interval here. So that's why we should be having a huge space, huge area. So that's why we'll be denoting them with, if it's a line, a straight line, then if it's a line like this, if it divides like this, the x-axis into two parts, then we can say the right half will be a right half plane and the left part will be a left half plane. And if it divides as in slanting line, then it will be the upper part will be called as upper half plane and the lower part will be called as lower half plane. So these are the things we should be keep in mind. So before getting into the solutions of our linear inequalities in terms of graphical point of view. So here comes our first graphical solution. So as I mentioned, before getting into our inequality solution, the first thing here is we will be talking about our equality. Right. So this is my equality, that is ax plus by is equal to c. This is my equation. Yes or no? Equation, linear equation in two variables. And you guys are completely aware of how to locate this typical linear equation in two variables on a graph. Right. So if we, how we'll be locating, if I take some x value, correspondingly we'll be having the y value. So based upon the coordinates of the point, we'll just simply locate the graph of our given equation. So here I have considered our equation ax plus by is equal to c. Right. So if I plot the graph, it will be looking something like this. So this is my line of the equation ax plus by is equal to c. So it will be, so the solution, the points of this entire line will be lying exactly on this line, exactly. Yes or no? Right. So now let's see for our inequality part. So my first case for my inequality is ax plus by greater than c. That is ax plus by greater than c. Right. So whenever I am having this inequality greater, it will be counting the upper part. Right. So if this is my line equation here, then this will be my upper part and this will be my lower part. Yes or no? Right. So whenever we are having any equality, so the first and foremost thing which we'll be doing is we'll just take that to be an equal to. Right. So we'll just take that to be an equal to. So for suppose this is my inequality ax plus by greater than c. So instead of that, what I'll take as a equality, as a equation ax plus by is equal to c, and I'll be constructing or locating my graph of this equation of line. Right. So once I could able to get my graph, so this is my graph of line, then I'll be getting into my inequality. So what is the inequality? Simply the greater, which means the upper part. So this entire part is nothing but my solution here. So simply in graphical method, what I can do, I can plot my graph of the line where I take it to be equal to, and then based upon the inequality, if it's a greater, then my solution will be upper half part, upper plane. Right. So let's get into the next case, that is when I am having greater than equal to. So even if we are having greater than equal to, our first step here is by taking it to be an equation, that is ax plus by is equal to c, and then we have plot the graph of this c. And now we'll just verify the inequality which is given here. So the inequality is ax plus by greater than equal to c, which means it is greater than the line as well as equal to, which means what will be our solution here? So this will be including the line. So including the line and the upper part of the line as it's a greater. So this will be my solution of this second case when I have my equation with inequality greater than equal to. Right, so whenever we are having equal to, that particular thing will also be equated, that will be also included. So here's the same thing, our line will also be included here, that is ax plus by plus c. So the points which will be lying on this line will also be considered as the solutions here for this inequality of ax plus by greater than equal to c. Right, so this is our second case of graphical solution. So let's move on to the next case here. So the next case for a graphical solution we are having is ax plus by less than 0, or simple less than 0 we are having here. So ax plus by is equal to c, that is our first step. So let me take the line here. So this is my line. And what is my inequality here? So my inequality is lesser. That means the lower part, the entire lower part of this line. And here the line is not included because there is no equal to sign here. So only we are given with the less than inequality. So only the lower part of the line. So this will be the solution of our third case where we have only the lesser than. So moving on to our next and fourth case here, that is graphical solution of a equation of a inequality ax plus by less than equal to c. So even the inequality is changed. What is our first step? We'll be equating as a equation. So ax plus by is equal to c, and we have plotted already the graph of ax plus by is equal to c. Right. So now what is the inequality here? Less than and equal to. So whenever we are having equal to, it even includes the points which are located on the line ax plus by is equal to c. So the entire points which are lying on this line will also be considered as the solution of this given inequality ax plus by less than equal to c. Right. So as this is included and the inequality is less than, that means along with the points lying on this line and the entire lower part, lower half part here will also be my solution of this typical inequality ax plus by less than equal to c. So here we have seen our four cases. Whatever the case might be, whatever the inequality might be, the first thing will be, we will be taking it to be an equation and just simply plotting the equation on the graph. So once we are done with that, and then we will be verifying what is the inequality which is given. If it is greater than, it will be the upper part. If it is greater than equal to, it will be along with the line and the upper part. If it is the lesser than, it will be the lower part. If it is less than equal to, then it will be the lower part as will be the line. So this is how we'll be plotting the solution and getting the graphical solution of any inequality. Right, so I hope you guys are clear with this graphical solution part. So let's quickly solve one just question in our graphical method and then we'll just move ahead. So I have given a question here. So quickly find the graphical solution, guys. So first thing you have to plot the graph. So what is the inequality I have given? 3x plus 2y greater than 6. So this is my inequality. So quickly find the graphical solution here for this inequality, linear inequality in two variables. So you can take with two points, that will be okay to locate the graph of this typical equation. So here the given inequality is nothing but 3x plus 2y greater than 6. So what is our first step to get the graphical solution here? So we'll be considering that to be as an equation. So that will be 3x plus 2y is equal to 6. So once we are having a linear equation in two variables, we are very familiar with plotting the graph of this typical linear equation in two variables. Quickly plot the graph of this equation, guys. Equation of line 3x plus 2y is equal to 6. So two simple coordinates of points, you can find it. So what can be my coordinates here? So if I substitute my x value as 0, I'm just taking a box here, only two values I'm trying to find. So if I substitute my x to be 0, then what will be my y here? So this term will become 0, 2y is equal to 6 and y will be 3. So when my x is 0, my y value will be 3. Similarly, we check what happens when my y is 0. That means this term will be present here and this term will become 0 equal to 6 and 3x is equal to 6 where x will be equal to 2. So when my y value becomes 0, my x value is 2. That means we are having 2 points here. That is, what are the coordinates? 0, 3 is one coordinate and 2, 0 is my other coordinate. So let's plot these two coordinates first. So x2, so 1, 2 somewhere here. So 2, 0, let it be here. And 0, 3, so 1, 2, 3. So somewhere here. So our line will be like this. So if the plot of the graph, that is this line is nothing but 3x plus 2y is equal to 6. So this is my graph of the equation, linear equation in two variables. 3x plus 2y is equal to 6. But I have to get my solution for the inequality, that is 3x plus 2y greater than. So whenever we are having greater than, that will be covering my upper part. Here there is no inequality, so there will not be the points on the line will not be included. So only the upper part here will be my solution. So we can show it in this shaded area. So this upper part above the line, all these points will be my solution of the inequality. So this is how we'll be finding the solution of linear inequalities in two variables using our graphical methods. Right. So I hope you guys are clear with this graphical method of finding the solution. So if you are having any questions, you can let me know. So we'll just start our wavy curve method in our next session, guys. So we are running out of time. So we'll just start our wavy curve method in our next session. So we can have a clear discussion of that in our next session. So that's all for today. So in our today's session, we just discussed our graphical solution as well as our operations, as well as we have seen the questions related to our inequalities, and we have even seen how to convert our given word problem into a linear inequalities and how we can simplify and find the solution of the inequality. So I hope you guys are clear with it. So if you have any doubts, please let me know, guys, so that we can have a discussion. If not, we can just wind up our session today and we can continue the rest in our next session of linear inequalities. So any doubts, guys? quickly let me know if you're having any doubts. If not, we can just wind up our session. So, okay, guys, I hope you guys are clear with this today's session. So, we are just winding up with this, and rest we'll just continue in our next session of linear inequalities. So, thank you, guys.